Hi everyone, so here we are on chapter 16, which is on covalent bonding. So this is different than the ionic bonding that we talked about in the previous chapter. So remember that your ionic bonds transferred electrons in order to obey the octet rule. So in this chapter, the covalent bonds are not going to be formed by transferring electrons. They are going to be formed by sharing electrons, okay? So they share electrons in order to obey the octet rule to be stable like one of the noble gases, okay? And then don't forget that to identify if something is covalent or molecular, you have non-metals together, okay? Non-metals together. And then we're going to get into drawing what we call Lewis dot structures. But before we do that, let's go over the different types of bonds. If we draw one line, a single line like this, that's called a single bond. Each line represents 2 electrons. Okay, so each line represents 2 electrons that they can share in order to make a bond. So right here we have 2 lines, okay, we call that a double bond. Therefore, that represents 4 electrons. Then if we draw 3 lines, that is what we call a triple bond, and then that corresponds to 6 electrons being shared. Okay, so this will make more sense as we get into the next step, which is on Lewis dot structures. Alright, so I'm going to show you how to draw Lewis dot structures. And the Lewis dot structures kind of give us a better picture of how these molecular compounds are being bound and how the electrons are being shared. And then a little bit later, this will lead into their shapes and geometries. So yes, these molecules have different shapes. All right, so here we have Cl2, diatomic chlorine. Now the first step to Lewis dot structures is you need to add up the valence electrons. So remember, valence electrons are the electrons in the outermost energy level, okay? And the reason why we are so concerned about the valence electrons is because remember, those are the ones that are actually used in bonding. So find chlorine on your periodic table, and then you should find that it's in group 7, okay? And notice that there are 2 chlorines, so then we're going to add up 2 chlorines. So that means 7 plus 7, right? Because chlorine's in group 7. So this means we have a total of 14 electrons. The reason why we're adding up the valence electrons is because this is going to tell us how many electrons are used in bonding for this molecule. So we can see then we're supposed to use 14 electrons in order to show the bonding for Cl2. All right, so first thing you do is you sketch out your molecule. And the thing is that you want it to make it look as symmetrical as possible, okay? So this one is pretty easy. It only contains 2 elements. So I'm going to write chlorine side by side. All right, so 1 chlorine here and 1 right there. Okay, so what we have to do is we have to make sure that both of these chlorines obey the octet rule so that they have 8 valence electrons around them, all right? So first step is we added up the valence electrons, all right? So we already added up the valence electrons. The next step is make sure that everything has 8 around it, okay? Because it has to be stable. And it doesn't matter that chlorine is group 7. We only use the valence electrons to help us determine the total number of electrons that we need to use in bonding. All right, so I'm going to put 8 around this chlorine. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, then I'm going to put 8 around this one. 2, 3, 4, 5, 6. And then notice here in the middle, all right, that these 2 electrons here are touching this one, and it also touches this one. Okay, so then this one has 8 around it. And this one here also has 8 around it. So let's just double check. 2, 4, 6, 8, right? That one has 8. 2, 4, 6, 8. And then that chlorine also has 8 around it. So you can see that right here, they are sharing those 2 electrons, okay? They are sharing those 2 electrons to make a bond. all right? And so that both of them can obey the octet rule. So that's pretty much what's happening with your covalent bonds and how they're formed, is because now they're going to share electrons. They're going to work together as a team so that both of them can be stable, all right? And then we go back and check. We were only supposed to use a total of 14 electrons. So we're going to count all of them up together, and hopefully it adds up to 14. Okay, so let's count. All right, so 2, 4, 6, 8, 10, 12, 14. All right, and that matches. Now, instead of leaving the 2 dots here in between them, what we can do is we're going to switch that out into a single bond. All right, so let me show you what that will look like. So let me see if I can erase. And there you go. So that's what the Lewis dot structure would look like for Cl2. Okay, so let's just summarize the steps here. First step is count valence electrons. Count valence electrons. Okay. Put 8 around everything. So 8 electrons. So put 8 electrons around everything. Okay. And then and then check the total. So you want to check the total number of electrons that were actually used. So that's what we did. We counted the valence electrons, right? And that added up to 14. Then we put 8 around everything, right? And then we checked the total, and it matches the amount that we were supposed to use. Now, what if it didn't match, all right? Then that's when we would go and try a double bond, okay? And then if the double bond didn't work, then we would go and try a triple bond. So we'll do an example like that a little bit later. All right, so let's do another example here. Okay, CH4. So the first step is add up the valence electrons. So we look at our periodic table. Okay, carbon is in group 4, right? So 4 plus. And then hydrogen is in group 1. And then there's 4 H's, so that equals 4. So in this one, we're only supposed to have 8 electrons, all right? Now, if you have carbon in your molecule, carbon likes to be in the middle. Since carbon is found in group 4, it can make 4 bonds. So anytime you see carbon, put carbon in the middle, okay? And so what we're going to do is sketch everything out with single bonds first, all right? Sketch everything out with single bonds first. So when you draw your bonds off of carbon and you're trying to make 4 bonds off of carbon, it's going to look like that. Remember, each line represents 2 electrons, okay? Now, there's a rule for hydrogen. Hydrogen can only have a maximum of 2 electrons around it, so that's called the duet rule. Because if you notice, hydrogen is in group 1, sorry, not group 1, well, it is in group 1, but I'm referring to row 1. So it's in row 1, and there's only 2 elements in the first row, so it only needs 2 electrons to be stable, okay? So hydrogen can never be in the middle. Hydrogen is always going to be in an attachment coming off of the central atom. Central means the atom that's in the middle. So then these are going to be H's coming off of it. So this is what it would look like. Okay, so we have carbon in the middle. Okay, and then we put the 4 H's around it. So this is called this skeleton structure. So skeleton structure means we're just going to sketch it out with single bonds first, and then you put the dots around everything so that it has 8 around it. So we're just going to check this carbon here. It should have 8 electrons around it. So remember, each line represents 2. So 2, 4, 6, 8. Okay, so that carbon has 8. Hydrogens can only have a maximum of 2 electrons around it. So that one has 2, that one has 2, this one has 2, and that one has 2. So we have to check and see to make sure that all of the rules are obeyed, all right? Everything has to have 8 around it. Hydrogen can only have 2. Now we're going to add up the total that were used in our Lewis dot structure. 2, 4, 6, 8 is the total, and it matches the total that we were supposed to use. So then this is telling us that we drew the structure correctly. Okay? All right, let's do one more example. So this one, let's do diatomic nitrogen. All right, so find nitrogen on your periodic table. You should notice that it is in group 5, and there's 2 of them, so 5 plus 5. So this one we're supposed to use 10 electrons. Okay, so I'm going to write nitrogen, sketch it out. Nitrogen side by side. We try it with single bonds first. Okay, now we're going to go and put 8 electrons around, or make sure everything has 8 electrons around it. So it already has 2 right there, so I'm going to add in the rest of those. 4, 6, 8. Okay, then I go to the other nitrogen here. Well, it already has those 2, right? 4, 6, 8. Okay, both of them have 8 around it, so both of them are stable. But now I'm going to add up the total. So we're going to add up the total that we used. Let's count how many that is. 2, 4, 6, 8, 10, 12, 14. We're only supposed to use 10. Okay, so that means we used too many. So now we try a double bond. When you place a double bond in, it is going to erase 2 dots on both sides. So it can get rid of, you can get rid of any 2 dots on both sides of that double bond. So let me see how I can erase those. All right, so notice that I got rid of 2 dots on both sides. All right, so every time you add in a double bond somewhere, then you erase 2 dots on both sides. It doesn't matter which ones you erase, just as long as you erase 1 on each side. Okay, and notice here around this nitrogen, it still has to have 8 around it. So let's check it. 2, 4, 6, 8. Then this one also has to have 8. 2, 4, 6, 8. So both of them have 8 around it, so they are stable. All right, let's count the total, and let's see if it matches. 2, 4, 6, 8, 10, 12. Still too many. All right, so let's place another bond. And then you have to erase 2 dots on both sides. All right, so it doesn't matter which 2 you erase, just erase 2 dots on both sides. Okay, so I erased 2 dots on both sides, and now let's check, make sure both of them have 8 around it. So 2, 4, 6, 8, and let's check this one. 2, 4, 6, 8. And then add up the total. 2, 4, 6, 8, 10, and it matches. So this is telling us that a triple bond works, all right? So once again, the rules are you have to add up the valence electrons, start with single bonds first, make sure everything has 8 around it, hydrogen can only have 2, and then add up the total that you used in your structure, and if it matches, then you're done. If it doesn't match, you try a double bond. Okay, when you put in a double bond, you erase 2 dots on both sides, all right? And then add up the total again. If it still doesn't match, put in a triple bond, erase 2 more dots on each side, okay? And then verify that it matches the total that you used. All right, so that is the beginning of chapter 16. You absolutely have to know how to draw Lewis dot structures, okay? Being able to draw the correct Lewis dot structure is going to depend on the rest of your answers for the other stuff that you're going to learn in terms of shape and polarity. So it is extremely important that you work really hard to know how to draw Lewis dot structures, okay? It is the foundation of this chapter. All right, I will see you later. Bye.